So we start off with figuring out the total cost equation. So we know that 2k is the capital and 24L is the labour, and we assume there aren't any fixed costs, so we know that the total cost is equal to those. So we can rearrange them like this to get the gradient for the slope, so you know that it's quite steep already. And then we move on to the Lagrange multiplier. So we insert the factors of Cobb-Douglas in there and the total cost into there. We then take out the factors that we need, which is k and l. So first we take k and we differentiate just the k factor, which leaves us with this 12.5k to the power negative 0.75, and then minus 2 multiplier equals 0. And then we do the same for L, which leaves us with 25k to the power of 0.25, L negative to the power negative 0.5 minus 24 multiplier. We then, use the multiplier to rearrange the equations to equal the multiplier, which allows us to do a simultaneous equation, which is up here. And we use the simultaneous equation to simplify it and to try and find the value of k. So we cross multiply, which leaves us with 300k to the power 300k to the power negative 0.75 and L to the power 0.5 equals 50k to the power 0.25 L minus to the power minus 0.5. We then divide it through, simplifying it, and we then simplify it again, which then leaves us with another easy cross multiplication, which leaves us with k equals 6L. Now, because we know k is 6L and that q is 100, we can put both these factors into the Cobb-Douglas to find L. So we start off with the Cobb-Douglas and then integrate 6L into k, and then we multiply it through, and then we simplify it here. So we know that q is 100 and there's a 50 before the Cobb-Douglas, so we just divide it by 50 to take that out, so it means it's 2 equals 6 to the power 0.25 L to the power 0.75. We then simplify that again and rearrange it to give us an L, and then we cube it. We square root cube it to get the exact figure for L. And then we know k is 6L, so to then figure out k, simple, we just put in the same equation we had for L times by 6. And that leaves us with these two figures as the for the optimization minimal. So L is 1.386722549 and K is 8.320335292. So capital is a lot higher than labour at this point. To figure out the total cost, we already know the equation we figured out at the beginning, which is TC equals 2K plus 24L. So we then factor in these, and that gives us the total cost of 49.92201175. Increasing the constraint to 101 changes the way we figure out the value for L. It changes it very marginally. So we go back to where we got to where we integrate the value here, and then we just change it here. So instead of 2, it would be 2.02, and then you can just factor that straight into L there. So then we go back and we get L1 as 0.75, and then we get 2.02 there instead. And then K is the same with the 2.02 in, which then increases our total cost to 50.5887455. So there's a marginal increase in the total cost. And to answer the final question, if you go on to double the wage paid, 44L would increase to 48L, which greatly increases the total cost. It would increase it by quite a significant amount because the labour cost is so much higher than capital. It would push the total cost up quite significantly, and it would really steepen the negative 1/12 gradient.